So the question is, what is the difference between equations and inequalities? Well, what you need to know is equations give you specific solutions like x equals 2, x equals 10, x equals 5, etc. And someone actually said the word etc. means you have reached the end of your thinking capacity. People. Now, what about inequalities? Well, you need to know that inequalities, they simply give you a range of solutions. They don't give you a specific solution, but a range of solutions. For instance, x is less than 2. What is the meaning of this? It means it's all the values of x in this range or in the interval negative infinity all the way to 2. It can be 1, it can be 1.9, can be 0.50, negative 10. We don't care as long as it is less than 2. So that's the main difference between equations and inequalities, all right? Now, in grade 10, we taught you how to solve for x in linear inequalities, but now we are going to be focusing on quadratic inequalities. So let's say you're seated peacefully in the exam, minding your own business, and they decide to ask you to please solve for x in this quadratic inequality. Well, the first thing you need to do, of course, is to write this inequality in standard form. So this is how it's going to look like. Then now it's time for you to factorize. So you open two brackets and say this is greater than 0. Then you say factors of x squared, it's x and x, and factors of 3, it's 3 and 1. The bigger number always takes the sign of the middle term. It never compromises. But in order for these factors to add up to 2, well, that's if this one is positive. Because negative 3 plus 1 is indeed negative 2. Then after saying this, after factorizing, you have to state your critical values. What are critical values? Those are simply the x-intercepts of your function, all right? And you really need to specify that they are critical values. Tell us this. So what are they? Well, you just solve for x here. You begin with the smaller one, x equals negative 1, and x equals 3. You don't say or, you say and. That's the difference, all right? And as I was marking you, I actually realized that you don't really understand the meaning of your inequality sign. You don't understand this greater than, less than, greater or equal to, and things like that. Well, let's try to help you to understand this, all right? Now, this is a function. Well, maybe it's much better if I say this. This is a function. It's a quadratic function. It's like this question is saying, for which values of x is f of x greater than 0? Ah, this one you recognize it because you have seen it in functions. So we call these the inequality function, in fact, questions in the context of functions. Now, what is the meaning of f of x is greater than 0? Well, in English, it means where the graph of the function is above the x-axis. But if it was less than 0, it's below the x-axis. So that's what the question is saying in simple language. It's where the y values are negative. All right? Now, after stating this, it's highly advisable that you go and make a small sketch of the graph of the function. All right? Well, we know that this is a quadratic function, and since the coefficient of x squared is equal to 1, it means your function is facing up like this. So now that you have sketched your function, and you know that your critical numbers of values, in fact, which are the x-intercepts of your function, this is where they're going to be. Now the question is, where is this quadratic equation, or rather function, positive? Where is it above the x-axis? Well, this is where it's above the x-axis, and this is also where it's above the x-axis. So here you say, well, this function is above the x-axis for all the values of x that are less than -1, or it's for all the values of x that are greater than 3. Do you see that? And you don't include your -1 as well as your +3. Why? Because at exactly -1 and at exactly +3, the function is not positive. It's actually at the x-intercept, which is where y is equal to 0. So at those values, f of x, the function itself, is equal to 0. No, we don't want where it's equal to 0. We want where it's greater than 0, where it is above the x-axis. So yes, that is your solution in this case. Now the question is, where are the marks? It's a very good question. Well, if it's not given to you in standard form, you can get a mark for writing it in standard form. And then you're also going to get a mark for factorizing. And please never use the quadratic formula when you're solving inequalities. I'll show you how to cheat it if you don't know how to factorize. But never use the quadratic formula. Always show them the factors. And then there's always a mark for your critical values. And if it's 4 marks, well, you'll get 1 mark for both of your solutions. So that's how the marks are normally at. But of course, if it was already given to you in standard form, then each of your solutions was going to get a mark. So yes. So well, let's say they give you this function. They say to you, here you are given x squared plus 5x, and this is greater or equal. In fact, it's less or equal to -4. So we know that the first thing is to write this equation in standard form. So well, the 4 becomes positive when it gets to the left-hand side. Then it's time for us to factorize this quadratic equation. Factors of x squared is x and x. Factors of 4, such that if we add them or subtract them, we get a 5. Well, that's 4 and 1. And both of these factors have to be positive. Then now it's time for us to state our critical values. And as we said, you always explicitly state this. You begin with the -1, in fact, the smaller one. Wanted to say that. Oh, well, I'm lying to you. -4 is smaller than -1, right? Then in order for you to correctly identify the solution, I strongly recommend that you represent the graph of this function on a graph. So you graph this, you visually represent it. Once again, the coefficient of x squared is positive, so the graph is facing up. And these are your critical values. It's -4 here and -1 there. Now, what is the question saying? The question is looking for the values of x for which the function is either negative or equal to 0, where the y values are either negative or equal to 0, where the graph of the function is below the x-axis. And this is actually where the graph is, below the x-axis. Do you see that? So it's for all the values of x that are between -4 and -1. And how do you say between in mathematics? Well, you say it's less than this, but greater than that. And of course, we are including -4 and -1 because at exactly -4 as well as -1, the y values are equal to 0 because those are the x-intercepts of the function. So a mark for writing this in standard form, for factorizing, for stating the critical values, as well as for writing the solution. So, well, what about in this case? Let's say they give you 6x squared, and then they say -5x. Well, actually, let's write it exactly as they gave it to you so that you know how to deal with it if it arises in the exam. So here they say you have 4 plus 5x, and this is greater than 6x squared. All right? Yes, that's what they say to you. You need to solve for x. Well, the first thing that I want you to do is to take all the terms to the right-hand side so that you're left with 0 on the left, and then you say this is greater than, and then you say 6x squared minus 5x minus 4. Now, I want you to understand the meaning of what you just said here. Here you are saying 0 is greater than 6x squared minus 5x minus 4. But then saying that 0 is greater than that, it's exactly the same as saying 6x squared minus 5x minus 4 is less than 0. Do you see that? If the age of Madlala is greater than the age of Einstein, then it means Einstein is less than Madlala. Do you get it? Yes, it's the same logic. Now here, you don't really need to divide throughout by anything. It's perfectly fine if it's like this. It's already written in standard form. You don't need to divide by, no, in fact, you can't divide by anything because if you try to divide by 6, you generate a fraction. You'll now be having 5 over 6 and 4 over 6. And remember, we try by all means to avoid working with fractions. And remember what I told you, you don't use the quadratic formula in inequalities, but you can actually use it, but don't show it, all right? No. What we want to see here is the factors, nothing more and nothing less. So you can quickly go to your calculator and substitute into the quadratic formula. You say negative into -5 plus the square root of -5 squared minus 4 into a, which is 6, c, which is -4, and then divided by 2 times 6. Then you get a solution. You find that x equals 4 over 3. And then you say, you do the same thing, but now using minus. So you find that x is negative half. Well, let's substitute again just to make sure that I'm telling the truth. I tend to be a liar sometimes. Never believe what I tell you guys. In terms of the values, of course, like x equals 4 over 3 and negative half. Always test it out and see if it is correct because I make mistakes. So please always verify what I'm saying. Okay, so yes, seems like I'm telling the truth. Yes, x is supposed to be 4/10, and it's also supposed to be negative half, right? These are the values of x that you get when you plug everything into your calculator, right? But now you're going to take these values and you reverse them so that they give you the factors. Now the question is, how do you reverse them? Well, it's easy. You want to destroy this fraction on the right, so you multiply by 3. So what do you get when you multiply by 3? Well, you simply get 3x, which is equal to 4. And if you take this one to this side, you get 3x minus 4. Do you see that? That becomes your first factor, 3x minus 4. Now, what about your second factor? You still do the same thing. You reverse this. You multiply this by 2 and by 2. So now you have 2x on the left and you have negative 1 on the right. You take this one to the left, it becomes positive. So now you have 2x plus 1. You use the quadratic formula, but you don't show it because here we don't want to see the quadratic formula. We want to see the factors. So now you know how to cheat this one out and have your happiness complete. If you didn't understand this, that's okay. We'll still do another problem similar to this one, so you should be able to understand. Then it's time for you to state your critical values. So you'll tell them that x equals negative half and x equals positive 4 over 3. And once again, you go to your quadratic equation, not really equation, but function, so that you see how the function looks like. And the coefficient of x squared is positive, and the function is facing up. And the question is looking for the values of x for which the function is negative below the x-axis. So now you'll say, well, the function is below the x-axis where x is less than 4/10 but greater than negative half. Because this is negative half and this is 4 over 3. So yes, please make sure that you understand the inequality signs. That's the main thing that I saw as I was marking you, as well as using this quadratic formula. Please don't do that. We don't do that here. So you're going to get a mark for writing this in standard form. You don't really leave it like this. No, 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 no. No, you don't leave it like this. We really appreciate it when the function is on the left-hand side of the inequality sign. So for standard form, for factorizing, for critical values, as well as for the solution itself. Well, I didn't really intend for this video to become long, but it seems like it's going to be long. So, of course, it's not really possible. Well, it's possible for some people to watch it right through without taking a break, without pausing or things like that, and still understand everything that I sent. But if you are like me and your concentration span is not really that long, so you can just take a break, pause the video and go and do some push-ups, jumping jacks, and come back and enjoy the video so that your happiness may be complete. All right. Now, let's say they ask you to please solve for x in this quadratic inequality. You have 2x squared minus 5x plus 3. And by the way, it won't always be 4 marks. Sometimes it can be 3 marks. Right. So then what do we say here? Well, it's already written in standard form, so we don't need to do anything further. We just need to factorize. But if you don't know how to factorize this quadratic function or equation, which has been, or rather expression, where the coefficient of x squared is not 1, then you just use your quadratic formula. You go to your nice calculator and say negative into negative 5 plus the square root of negative 5 squared minus 4 into 2, and then you times this by 3, and you divide everything by 2 times 2. So we find that x equals 3 over 2, or what? Or x equals 1. That's fine. Now this one, which is a fraction, we have to reverse it by multiplying both sides with the denominator so that we get 2x, which is equal to 3. And of course, if you take your 3 to the left, then this is what you get. So the first factor will be 2x minus 3. And here we have x equals 1. So you just take the 1 to the left, it becomes negative. And after this step, of course, it's time for you to state your critical values. So you'll begin with the smaller one, which is 1. And what is the bigger one? Well, the bigger one will simply be what? 1.5, 3 over 2. And also, in mathematics, we appreciate fractions, not decimals. Although decimals are not wrong, please always try to work with fractions. Unless if it's in maybe you're solving a quadratic equation using the quadratic formula, and it has to be written in decimal form, then you can use the decimal. So we now understand that we are looking for where the function is below the x-axis. And for this one, I'm not going to draw the graph, but since the coefficient of x squared is positive, I know that the function is facing up, and where it's negative, it's for values of x that are less than 3 over 2, but greater than 1. So yes, you can sketch that graph and see if what I'm saying to you is actually true. But it is true. But of course, don't trust me, right? Always go and verify what I'm saying to you. That's wisdom. Don't just accept things as you are told them. No, no, because you are scientists. You are studying science. And the origin of science began with a Greek man called Heraclitus centuries ago. And this guy, Heraclitus, he was a Greek, as I told you. He actually told his students to observe things. He said, watch the clouds, watch the weather, find the reason why the weather behaves as it does. And he called it meteorology. He said, watch people, watch the behavior of human beings amongst the society. Try to find the reason why people behave as they do. And that is called sociology. Study the animals. Why do animals behave as they do? Zoology. Why does the human mind behave as it does? Psychology. So as a result, every branch of science has an ology. It ends with an ology, which means the reason why something is behaving as it does. So Heraclitus, he didn't accept the things that he was told. He wanted to find the reason why. So similarly, please don't accept everything that I'm telling you. Go and investigate, do research for yourself and see, oh, well, he's actually telling the truth. All right? Yes, but I promise you, everything that I'm telling you is the truth. Because if I don't tell you the truth, I'm actually saying you should fail in the exam. Imagine. But nevertheless, and sorry for that short history lesson, but I know you appreciate it. That's why you are my student. So what about in this case? Well, here they say you have x minus 1 times x plus 4, and this is greater or equal to 6. If we had a 0 on the right-hand side, we were going to go ahead and state our critical values because then it will have been given to us in factored form already. We don't need to expand if it was 0 on the right-hand side. But now it's not 0 on the right, it's a number, a non-zero number. So it's really necessary for us to expand this, collect the like terms, and write this inequality in standard form. So we are going to use the FOIL method. I strongly believe you still remember how it works. So x by x, we get x squared. X by 4, we get a 4x. Negative 1 by x, it's negative x. Negative 1 by 4, negative 4. But then we take our 6 to the left, and it becomes negative. Then now we write this expression, or rather inequality in standard form. So 4 minus 1, it's positive 3. Yes, I'm not sure why I just wrote an x there. 3x. And then negative 4 minus 6, that's negative 10. And this is greater or equal to 0. You can still use your quadratic formula in order to try to find the factors, but this is really an easy one because the coefficient of x squared is 1. So you can just go ahead and factorize this. Factors of x squared is x and x. Factors of 10 such that if we add them or subtract them, we get a 3. Well, that's actually 5 and 2. The bigger number takes the sign of the middle term, and of course, this one has to be negative. And now it's time to state the critical values. Well, that's going to be negative 5. And you don't say, oh, it's and positive 2. Because as I told you, x-intercepts are negative 5 and positive 2. All right? So now it's time for us to state the solution. Well, I'm not going to sketch the graph once again, but remember, I strongly advise that you do, because I now know these things, right? So, well, I'm sorry, I'm not really trying to brag or anything, but I'm just saying that I know these things, so I don't really have to do everything. But you as a learner, you really have to do everything. Remember, you can never be too careful. It's better safe than sorry, they say. So yes, I already know that this is a quadratic function which is facing up because the coefficient of x squared is 1. I already have the picture in my head. I know how it looks like. And I know that where the function is positive, it's for any value of x that is less or equal to 5, or it's for any value of x that is greater or equal to 2. So yes. But it's really wise for you to sketch the diagram and give it a good look. Okay. So once again, if it's just 4 marks, then you know how the marks are, right? For standard form, factors, critical values, the solution, over and out. I think we still have 3 more problems to look at, if not 2. So let's give them a good look. I think I've told you most of the things that you need to be worried about with regards to inequalities. So this one, we are not really going to finish it. No, we won't finish this. Should we not finish it? No, let's finish it. Okay, so we have 3 problems that we still need to consider. This is the one I'm saying we won't finish, but we'll just finish it. So here they say x minus 2 squared is greater or equal to 1. And once again, we have a non-zero number on the right, which means we really need to expand and write this in standard form. All right? But then if it was 0, then how would it differ? Oh, well, if it was 0 on the right, then it means you are actually dealing with a quadratic equation, or rather function, that has been shifted 2 units to the right. So maybe let's say it's now something like this. The turning point is still on your x-axis, but the function has now been shifted 2 units to the right. So the question is, where is this function greater or equal to 0? Well, here we can see that it's positive for all the values of x, right? On the left of 0, on the right of 0. But then at exactly 2, we can see that the function is equal to 0. So what is the solution here? X is an element of real numbers. Or you can say x is an element of values from negative infinity all the way to positive infinity. Because here we are looking for 2 things. Where it is greater than 0 above the x-axis, which is the pink part, and where it's equal to 0, which is at 2. So, yes. But then since we have any number which is not 0 on the right, then it means we have to expand this. You repeat this bracket twice as you did in grade 10, and you use the FOIL method. And after successfully using the FOIL method, well, this is what you're going to get. And of course, it's supposed to be 4 there. Then you say minus 1 greater or equal to 0. Yes? And writing this in standard form, well, you simply have negative 4x there, and you have a positive 3, which is greater or equal to 0. That is an ugly greater than sign. Yeah, this one is much better. And then, of course, we factorize this. I think from this point, you should be able to proceed with it. Yes, no, I strongly trust you. Yes. So both of your factors have to be negative so that negative 3 minus 1, it's negative 4. But then if you're struggling to factorize, use the quadratic formula on your calculator. Don't show us the quadratic formula here. Don't forget to state the critical values. I'm not going to state them. I'm just writing the solution. So for any value of x that is less than 1, or for any value of x that is actually less or equal, greater or equal. Yes. Yes, these are your two solutions. Okay. Okay, I think I need a break because we still have two more questions to do. So, yeah, let me just go and do some push-ups and I'll be back. Right? Well, let's finish this. So, let's say they ask you once again to please solve for x, but in this inequality, well, here they say you have x plus 1, which is multiplied by 4 minus x, and this is actually greater than 0. But then here they attach a special condition. They say, well, this is where x is an element of natural numbers, which are simply the counting numbers 1, 2, 3, 4, 5, 6, 7, 20, 50, 100, and so forth. Those are natural numbers, but of course, excluding 0. It's the positive numbers excluding 0, and they must be whole numbers. So those are the natural numbers, all right? Well, the first thing I would like us to fix is this negative x because we always prefer, we always appreciate it if the coefficient of x is positive. Well, you don't need to distribute this entire thing. Like you don't need to expand the entire thing. You don't need to use the FOIL method. You can actually cheat this. How can you cheat it? Well, this is what I want you to see. You still write your x plus 1 there, but when it comes to this 4 minus x, you're going to take negative out as the highest common factor so that x is now positive and 4 is now negative. And of course, the result is still greater than 0. Do you see that? Then you can take this negative sign and put it outside of those two brackets. So this is your negative sign. And then you still have your x plus 1 undisturbed. And you still have your x minus 4. And this is greater than 0. But of course, we have to further divide by this negative. So you divide by negative 1 so that you have x plus 1, x minus 4. But now you say this is less than 0. Because we know that every time we divide by a negative number, the direction of the inequality sign will be reversed. Do you see that? Of course you do. So what? The critical values, I'm just going to say CV, but please remember to write it in full because the marker doesn't know what is CV. So please, you begin with the smaller one, which is negative 1. No. X equals negative 1 and x equals 4. So these are your critical values, all right? Then we now know that it's a quadratic function that is facing up because both of these x's are positive. So where this function is negative, it's between those two x-intercepts. For values of x that are less than 4, but greater than negative 1. Do you see that? You don't just leave it here because you didn't answer the question. They gave you a very important condition. x is an element of natural numbers. In other words, you need to write down the natural numbers in this interval. So we have the interval -1 all the way to 4. But then we know that these two values are not included in that interval. So which natural numbers do we have in this interval? Well, 0 is not a natural number, 1 is a natural number, 2 is a natural number, and 3. But we don't include the 4, even though it's a natural number, because it's not included in the solution anyway. But this is how you write it when they say x is an element of natural numbers. You won't say x equals 1 or x equals 2 or x equals 3. No, you're not going to say that. What are you going to say instead? You write it in set builder notation. So you say x is an element of a set of values, which will just be 1, 2, and 3. So that's the difference. You write it in set builder notation. But let's say maybe they said x must be an element of whole numbers. It's still an n, but with a subscript not. Yeah, you don't say a subscript is 0. It's a subscript not, as in like naughty. That's the meaning of that. All right. And not. Well, if they wanted whole numbers in this interval, -1 to 4, well, you're just going to add 0 because 0 is a whole number. Yes. But if they said x is an element of integers, it will still be like this because integers, it's whole numbers that are either positive or negative. But if they don't say anything, no, they don't say anything, then you just stop here. Because if they don't say anything, they are implicitly saying x is an element of real numbers. And by implicitly, I'm saying silently, like deep down in their hearts. They're just not saying it, but they're actually saying x is an element of real numbers. And a real number can either be positive, negative, whole number, or even a fraction or a decimal. So, yes. Well, if you didn't understand what I told you, please repeat this part of the recording once more until you do. So it's not really too much. It's not all bent. No. Yes. And by the way, I really, really hope that as you're watching the videos, the most important thing is to listen to what the person is saying in the video. Yes, the solution is important as well, but the most important thing that you have to do is to make sure that you understand how that solution was obtained. And in order for you to understand that is by understanding what the person is saying. Focus more on my words rather than what I'm writing here, because I'm explaining the concept in words, right? And applying it in mathematics. Right. Then finally, we have this one, which is a nice challenge. It's a very nice one. Of course, they can give you things that are not following the general pattern. This is when they expect you to think in the exam. So, what is this inequality saying? Well, we need to find the values of x for which 3 to the x times x minus 5 is less than 0. But if it was a question in functions, they would have said f of x for 3 to the x times g of x for x minus 5. And then they say this is less than 0. So in other words, where is the product of these two functions negative? Where is the product of the y values on these two functions negative? Now the question is, what are you going to look for? If it was functions, you are just going to look for where this one is either positive and this one is negative, or where this one is negative and this one is positive. Because in order for a product to be negative, one of them has to be negative. So that's what you'll be doing. But then since it's not really a question under functions, let's just look at this inequality and see how simple it is. Well, unfortunately, you can't do this if you don't understand your functions, if you don't have the knowledge on functions, because 3 to the x, that is an exponential function, right? Of course. And we know that an exponential function that is increasing is always above the x-axis. Always. This is how the function would look like. Right. It's coming from negative infinity, it's going to positive infinity in terms of the x values. But bottom line is, it is always above the x-axis. What about this? Well, g of x is a straight line that has a y-intercept at -5 and an x-intercept at +5. So what I want you to tell them is, well, we can see that this function is always above the x-axis. So that's what you tell them. 3 to the x is always positive. This is one way of saying it, or you can say 3 to the x is greater than 0 for all values of x that are real. It's still the same thing. You actually said one thing, but in two different ways. The first way was in English, generally speaking in English, but then the second way is a mathematical way. So you'll decide which one of these two to say. But then I strongly go for the second one. Think of it. So now we know that this one is always positive. So in other words, we now need to find where this one is negative. Then the whole product will be negative as a result. So we now say, well, where is this x minus 5? Negative. And if we take this one to the right, we can see that it's for values of x that are less than 5. And this is true. Very much true. Because if you go to the x-intercept here, which is at +5, for all the values of x that are less than 5, the straight line is negative. But then the exponential function will always be positive. And negative times positive, negative. Do you see that? So that's the solution. The other one is always positive. So we need to go to the one and find out where it is negative. Then the product of those two will be negative where g is negative. Yes. No, I think we should stop here with regards to inequalities. Yes, so I really hope I did assist you in terms of understanding inequalities and most importantly, the inequality signs. And I also tried to give you a feel of it in with regards to functions. So I really hope those inequality questions in functions will now appreciate them and destroy them. Thank you so much for watching. Over and out.